Hi, this is example 3 from exercise 5.02. So this is find the surface area of a curved shape. So we're asked to find the surface area of a cylinder with no top and a height of 12 centimeters and a diameter of 16 centimeters. So let's just draw that up to start with. This is my best attempt here on the tablet, so bear with me. We're trying to draw a tin can, but it's got no top. So in effect, if I cut this open, it would be a rectangle with a circle for the base. So this is the bottom of the tin can, and this is the side. So here we know that the height of the tin can is 12, and we know that the diameter all the way across, sorry dodgy, but it's 16 centimeters. So if that's the diameter, the radius would be equal to half, which is 8 centimeters. Now, the surface area, remember we make a net, so the net looks like this, the rectangle and a circle. The rectangle has a height of 12 centimeters, that's pretty straightforward. This long side here has pi r, 2 pi r actually, sorry, and the area for the base, the bottom of it, is pi r squared, because that's the area of a circle. This shape, the rectangle, is length by width, which is why I needed a length, and 2 pi r is the width, because 2 pi r is the circumference of a circle, and if I wrapped this side around, it would match the circle. Alright, so that's how we're going to roll with this one. The surface area then is equal to pi r squared, only 1 because it's got no top, plus 2 pi r times 12. All right, so I'm sorry about the dodgy writing here, but and r we know, we worked out, was 8 centimeters because it's half the diameter. All right, so pi times 64 plus, 2 times pi times 8 times 12, too much for my little head. If I put that into my calculator, it all comes out to be 804 centimeters, 0.25 centimeters squared. Okay, so remember to draw a net, and remember to consider whether it has a top or not. Okay, sliding along. A closed cone with a radius of 7.8 centimeters and a height, that would be a perpendicular height, otherwise I would declare it as a slope height, of 10.4. So we know that the surface area of a cone, hang on, let's draw that first. We've got a formula, which is why I leapt straight into that, but let's say the radius here was 7.8. Oh, I don't know how to write that in there, 7.8 centimeters, that's the radius, this section here. And the perpendicular height, trying to draw on my tablet, this is the height of the cone is 10.4 centimeters. All right, so where I was saying before, we have a formula. I think it's on your formula sheet, otherwise you're going to have to learn it. It's pi r squared plus pi r s. Now s is the slope height, and the slope height, I'm just going to change pin color, let's go orange. The slope height is out here, or in this case over here. All right, so this is s. Now we can find s easily enough. We use s is equal to the square root of the radius squared plus h, the height squared. So in this case, s is equal to the square root of 7.8 squared plus 10.4 squared, and s is equal to the square root of 169, which is equal to 13. All right, so now I can just put this back into the formula and use the s as well. So here we go, pi times the radius squared, radius is 7.8 squared, plus, put brackets around that, plus pi times the radius, 7.8 again, times this s, the slope height, is 13. If I pop all of that into my calculator, I come up with the wonderful number of 509.69 centimetres squared. So that's the surface area of the cone. Okay. The surface area of a sphere. Okay, let's draw that. Now remember, I'm trying to draw, I kind of do this to make it so it's not a circle. Trying to make it look like a ball or a globe. All right, now the radius from the center out to the edge of the sphere is 17 centimeters. And we have the straight up formula for the surface area of a sphere. It's equal to 4 pi r cubed, r squared. My apologies, pi r cubed is, would be the volume. Surface area is not the volume. All right, so 4 pi r squared. R we know is 17 centimeters. So the surface area, this is just plug and play. 4 times pi times 17 squared into your calculator comes up with 3632 centimeters squared. Okay, so that's the answer there. The last one, a closed hemisphere. Now this is a word that tricks some of you. Hemisphere is half a circle. Half a sphere, half a sphere. Goodness gracious me, I've not really woken up obviously today. Half a sphere. And it's closed, so that means like someone's put a lid on this. That's my best attempt. All right, so we put a lid on here, and it's like we've cut it in a sphere in half. So I have half a sphere. And the lid, of course, on top of the sphere would be a circle. The lid is a circle. So that's pi r squared. Yeah, the area of a circle is pi r squared. So my surface area for this shape is equal to half a sphere, which we just did, 4 times pi times r squared, plus the lid. The lid was pi r squared. It's just a circle to go on top of that. Now, we can simplify this before we even substitute anything in. Half of 4 is 2, so that's 2 pi r squared plus one more pi r squared. How many pi r squareds have I got? I have 3. 2 pi r, sorry, I think you can see my cursor and I know that you can't. I have 2 of them and I add one more, so I end up with 3. Okay, so now I'm going to just substitute in the value for the radius. Now here they said it had a diameter, or go back to this pen, it said it had a diameter of 42. So the radius would be half of that, which would be 21 centimeters. All right, so let's come back here. I can substitute the surface area equals 3 pi r squared when the radius is equal to 21 centimeters. So the surface area is going to be 3 lots of pi, lots of 21 squared. And that comes out to a beautiful number in my calculator, 4,156.32 centimeters squared. All right, so I hope that helps.